Hello everyone. My name is Michael. I want to showcase a little bit and guide you through our gate basically and run you through some developments we did over the last years basically that have like a data interoperability focus, and basically we talk a little bit about the developments we made in-house. So that's me basically. I joined the whole industry basically after my studies in 2008 already with the field of computational design. So basically and then went through over to BIM, and since 9 years I'm at Herzog Meuron, started as a BIM manager and now leading design technologies, which is a almost 30 people big group basically that I will showcase later. So Herzog Meuron is a partner-led company with some history. So we are over 44 years old basically, and we are 600 people working worldwide that basically are distributed over 8 offices. Our main home base is Basel basically, where the office was founded, and we work on different scales. So basically we have a lot of typologies, scales. We work worldwide basically. All the projects are distributed, so it's from very small furniture pieces until stadia and basically urban schemes that we're working on. And they're distributed on big parts of the world, not everywhere, but I think that's important to understand basically how we approach our projects basically from a digital point of view. To just give you an impression about some projects we did, Tate Modern, quite obvious, you all know, I guess, Elbphilharmonie in Hamburg. You see the architectural expression is very like geometry based basically. But it's not that we stick to that, so we have as well a very contextual approach in a way that this building like top of one of the mountains. We're in Switzerland based, so we have beautiful mountains, so we can cover them with nice wooden structures basically that are only assembled by cable cars basically and helicopters. And other projects like UCSF, a hospital we're currently developing in San Francisco, which has the idea, like many of our other hospitals, to have this user-centric approach that the hospital does not feel like a hospital basically, because the human should basically have a healing habitat. And what interests us as design technologies department is how to bridge design and technology. So we have ideas coming from teams, from partners, basically maybe how to let's say realize that image into some nice building, and we're there to realize that, to work together collaboratively with the team to make that happen basically. And design and technology in a way is not something that technology in a way drives the design per se. It can sometimes, like in cases like the Elbphilharmonie, which is very, let's say, expressive in terms of geometrical appearance. But sometimes you can't see it, like in this so-called X-Hocker, it's like there's a lot of parametric design in it, there's a lot of CNC fabrication, but you don't feel it in a way because it has some other ideas that kind of drive the whole topic. And we as well need to understand where we are in a team in a big company, and that's why we have to understand our own purpose. Why do we exist basically, and what is our role basically? We help the projects, each and every project, to basically realize those projects. And we need as well to understand how we approach that. So we don't approach that in a standardized way. I mean, we're always kind of trying to be efficient, but we'll look very precisely for each and every project on what kind of approaches we have to take in terms of technology. And what do we provide? So we have 4 main competencies, basically. We call them domains. So the core services are computational design. Then we have project delivery, which is BIM and still some CAD left. We, since some years, operate the physical workshops and included robotic fabrication, or will include robotic fabrication in the near future there. And we have as well the whole visualization and animation team with us. So this basically is like a big group that works together, basically. Everyone works in his own domain. But we have initiatives that span basically over multiple domains, so we can create cross-functional teams that with multiple expertise can come together and work on special initiatives we are very interested in to develop. And what are our challenges? I mean, I had to talk with Martin, thanks again for the invite, about what interests us. I mean, data interoperability and sustainability are, let's say, big topics we have to cover. And this conference is a lot about BIM 2.0, no? I mean, what is the future? And I think it's good to understand what is the present in a way. So what is the present? Our ecosystem is vast. So we have a huge ecosystem. It's very hard to cut it down, basically because each and every project in each and every country with each contract and contractual situation and role demands for something else, like open BIM, closed BIM, owner BIM. All these basically topics basically drive us to find the appropriate ecosystem for each and every project. So what's 2.0? And how do we handle it now? So basically, our way of approaching these, like these individual projects and finding the right approach is basically having like an applied research approach, basically. So we work on projects there, we develop those things, like progress them, we manage things there. But on the side, we as well have the flexibility into investigating into new things that are not in the current project portfolio existing yet, like as an approach. So what does it mean? We experiment, it's kind of hackathon-like. Then we formulate strategic initiatives that kind of bring these cross-functional teams together, that we say, okay, this is something we have to invest. We organize that with Kanban boards, agile developments, all these things. We bring them into daily practice. In between, basically, we showcase them through tech talks internally, and then we hopefully have some stable releases that are kind of part of the regular toolkit in a way. So I brought 4 chapters, basically, BIM 1.5 maybe, so maybe we're in between. Let's talk about services in general, maybe use cases could be another word for that. Open source is a thing, and what's next? When we start with BIM, basically, we saw like, let's say, when we started, it was a lot about geometry and sometimes creation of drawings only. So there was no real BIM deliverables, there was no real, let's say, full embracement of the methodology in a way. This has changed with, let's say, 3 key projects that happened more or less at the same time of 2014. I was very lucky to join the office back then as a BIM manager and as well heading one of these projects like the Children's Hospital in the middle in Zurich, but as well being involved in the other projects in Hillerød, which is in Denmark, a super large hospital development, and one of the large developments in Basel, basically. When you come to Basel, there's some skyscrapers. This is for the Roche pharmaceutical industry. And what changed here is this data-driven focus. So basically, there were room books like the Rufus, the client Roche developed their own, let's say, approaches to data. And we delivered basically fully, let's say, or had to devote fully to the BIM process, basically, on a very large scale at let's say, one period of time. And the interesting thing is that this basically, we had to understand what can we handle it. So basically, when you look at Kinderspital, the Children's Hospital, it's a very complex building, basically, that we're currently, as an executive architect, bringing on site too. It's like a city, basically. So this is like the ground floor of the hospital. So there's a lot of compactness, a lot of functions. You have to manage data management. There are a lot of things you have to do. So, but you coordinate as well. So there are multiple things you do on such a project, quite obviously, most of you know. But what was interesting back then, real-time visualization with Enscape, in our case, came up. And this gave the whole methodology, the whole investment to push, basically, which was very interesting, that over time, basically architecture takes some time, technology changes, and hopefully you can integrate it into the process to give it basically even a better meaning to work with these models, basically. And we're kind of very interested in controlling things, basically, so maybe we over-model sometimes, but we have to understand really precisely how things work out. And we'll do a lot of mock-ups, so in a way it matches very much our approach of understanding the complexity of a built project through, let's say, the virtual version of it. Some may say it loses the momentum when you know already how it looks like, but some say it's very good that you know how it looks like. And then sometimes we experiment with new technologies back then with the HoloLens on site, where we as well just tried to figure out, hey, where's the potential? So this is already some years ago. And then other technologies rise up, like laser scanning combined with AI, which is operated in the Denmark project, which as well kind of interests us, and we're trying to basically understand how this is run in that project and how we can transform it into the other projects, basically. So what did we do when it comes now to developments? We did a lot of coding, a lot of small tools, toolbars. This is only one project. And so it was kind of Pirate came up, a lot of like momentum, everyone, it's let's say a lower threshold in terms of coding. And we developed a lot of tools, and then basically it was clear, more coders on site. Before it was smaller teams working on it. We had to professionalize it, version all the things. And then somehow we figured out, hey, maybe we test one thing. It was kind of the idea. Okay, let's bring that out into the field, make it open source, basically, because the person behind that invested most of the time in his free time. He was so passionate about it. So Revitron came up, basically, which you can find online too. So where basically, what did we do? I mean, there were features we were missing. So you want a room tag always in the left upper corner, which is kind of makes a nice plan. Does not exist in the package. So basically, or you need some specific data, like all the height fields in the heights of all the elements, basically in the room tag. Does not exist. How do you do it on complex buildings, basically, with all the exceptions and stuff like that? So we had to develop these things. And then we figured out, hey, versioning does not exist at all. I mean, we knew that back then already, but with all these developments, we kind of managed to track on the side all the history of each transaction that we did in the BIM model. And we could identify who deleted what when and kind of recover the latest version of a door, because there was a huge data set behind that. So that was like a huge step, like 2014, and later basically all these things came up. And then we grew it in, more and more, so we tracked all the data, QA, QC, we could, let's say, identify having dashboards to have like alerting systems, basically. But we then ran everything to our boards, basically, our executive boards, strategic boards with all the partners, showcased what we're doing, why we do it, and then they gave us some feedback, which was quite interesting. Basically, they said, yes, yeah, okay, go for it, continue. But they as well gave us feedback in terms of kind of, or let's say we formulated together some let's say, directions and goals, basically, on different levels. And one of the goals, like, was reducing complexity. So how do we do that? I mean, like in early phases, basically, how can we be not overwhelmed by data but still use it, basically? So we defined something we call BIM Lite in a way, which is a Rhino-based approach. And at the same time, the BIM Plus, where we can say, okay, all these use cases have that complexity, and dear client, this is an increase of cost. So this is something very, very important, basically, to understand which, let's say, methodology in a way we apply it, in which phase to what, basically, that we can as well give a feedback into the investment from the steering side of the management internally, basically how many resources do we need for that, at the same time to the client, as I said, regarding costs. So when we look at the early design, so this is super fast, no? I mean, you can imagine we have a lot of options, a lot of people, and this is something you can't, let's say, you need something very lightweight that you can imply, basically, a little bit of information into it. So what we did is just taking some ideas of information and bringing into our main, let's say, early design package, which is Rhino from McNeil, and really having like this toolbar, which is our low threshold approach, basically. So it's very minimal invasive, so it's kind of doesn't change the whole system, it does not change the whole approach of working. You don't have to pre-structure a lot, basically, or actually you don't pre-structure anything. But the tool basically helps you in structuring to get the information in and out into CSV or Power BI. And then we track the data, see, did the people click on the buttons? Hey, why don't they click on that button? Okay, drop that development, move to the other one, or train the people, because it's a very cool button, you didn't click on that. So that's kind of this approach of really understanding how people use and utilize tools into the design process. And this kind of triggered basically the whole it started with 3 people basically, and now it's a whole group and a big part of the group that is kind of working on these toolbars, like not full time, but because it's very interesting to understand how people interact with these tools and try to basically optimize that workflow and processes that we utilize in design. So that's how it looks like, basically, just to give an impression. So it's just geometry, just level definitions, and use user attributes basically to apply some functions and basically come up with your own ideas of what it should be. Is it kind of apartments or whatever, or all these things basically you can define. So no prescription from our side as developers, really freedom and a low-key entry, basically like in half an hour you should really get it, what it does basically, and utilize in each and every project. Because the interesting thing here is how do you enter smart tools into the design process without, let's say, being there as a specialist? How do you scale, let's say, digital tools into and make a smarter process, basically a faster and more efficient process that utilize the tools without any, let's say, too in-depth expertise? Yes. So when we talk about the standards, which standard should we apply to? We're a Swiss company. We work as executive architects in Switzerland and in Germany and in France. So this is already a big chunk of work. We work as design consultants all over the world. So which is our standard? So this is kind of a big problem. So basically, over the years and out of these developments with Revitron and with kind of their conceptualizing tools for the whole office, basically, that are not only project specific, even they started being project specific. We came up with, let's say, the config, basically. We have everything needs a config file. Everything has a JSON somewhere that basically maps things. So the standard is not so the interesting thing. The interesting thing is how to translate from A to B, basically, or define something, and then it's machine readable and you can translate it again. So this is something we did, and basically when we had BIM Lite, we had to maximize as well the efficiency of our templates, for instance. I mean, in all the countries, all the templates, how to manage them, how to improve. So we created this meta template, which is instead of having like a Swiss, a German, a French, whatever template, which was very hard to manage. So if you had an idea here, you had to manually add them there. So we said, okay, this doesn't work. So basically, we have like this mega template that kind of you can, let's say, just customize, custom fit, and this is kind of only the starting point. And we developed that one that we can basically customize everything. Guess what? In the background with config files, basically they say, okay, you're a Swiss project with that scope for that phase. Okay, you get that content. Chapter 2, use cases or services. So we love to build stadia. So football stadium is something like the one of the most favorite typologies in the office. And it's about the audience. So you have to create like a huge, let's say, effort, or not a huge effort, but you have to really be precise on the geometry of the bowl that you have a great atmosphere. The Allianz Arena, I think I can recommend personally as well to go there. It's a great experience. But we don't do only stadia. So basically we have other auditoriums. Maybe the same problem we have faced there. Or we have something more simpler auditoriums that as well maybe have a fraction of the problems of what basically the audience and the actor has to be seen. So basically what we created for stadia, basically a rule-based parametric approach, in that case for the Stade de Bordeaux in France, is something basically we try to generalize again and try to bring into other projects, and that it's not only typology specific, but as well can be applied to auditorium, or let's say a more generic approach of basically a spectator and audience. Let's call it like that. And the important thing that it can be translated from a specialist to someone in the team who can be trained. I mean, it's in that case Grasshopper, but it can be very much trained basically to someone, and the team can operate the design by itself. And you can say, hey, that's all solved, no? The design is solved, interoperability is solved, we push everything through Rhino Insight or MKS Beam over to Revit, we can push the data there, good. You could say we're happy. But there's some use cases that are a little bit more, let's say, work or need some more developments which are not there on that level maybe as this one. Let me run that through. So we're very much interested into AR. So this is just a teaser. Basically, we'll have an upcoming exhibition in London in July at the Royal Academy, basically, where we showcase some of our physical models in our so-called cabinet, which is a foundation in Basel, which has these physical shelves, and there we enrich them with digital models. And this is something we do a lot, like we call this design experience. So the idea is really to combine, obviously extended realities, to combine physical models we create in the workshop, we mill them ourselves basically, with let's say, design experiences and enrich them and augment the user experience. And this is something that kind of appears on different levels. So we're as interested in mockups, as you saw. So we create all these XR mockups with baked textures. They are very, let's say, high detailed in a way. And we can create, let's say, multi-user experience with hologram, and as well bring that to the, let's say, one-to-one scale, because this is something interesting, no? The one-to-one scale to feel the presence of the building, basically. But yes, we get those models. What do? Most of them sometimes have issues, and then people work on that. They don't call you. So in a way, to really kind of be efficiently, let's say, with the models that, and let's say, an architect who is not that experienced of what it means basically to create that use case of an XR experience. That person needs to really work under pressure in a way, basically, to deliver us the right models. So what we do is kind of track automatically all the model qualities, like bounding boxes. Is there something floating around? Because this will, let's say, we import, we already lose 1 hour of work because basically the input was not so good as expected. So that's very important, basically, that we kind of understand which use case needs what. So just, I mean, this is just out of some presentation. This is just, I mean, bad objects, no? In Rhino, they're bad objects. Non-manifold polysurfaces. All these things basically can, let's say, crash the efficiency. So we need to automate them to find out where are, let's say, the bugs in the model that we, as specialists, don't spend too much time on, let's say, polishing these things up, or the team too. So all these use cases basically need those in-between intermediate workflows. Same for the VIS department. So our visual artist, together with the computational design team, basically these two domains, which are under one umbrella, they worked on mesh optimization for renderings. So all these things are very small, but if you don't have them, it's very time-consuming to, let's say, deliver those use cases and services. Another thing we very much like, but this is kind of still as well something that is not solved in a way, is kind of the moving XR experiences into urban scale. So we laser scanned the whole site, we projected everything in, but you can see already some drift and stuff like that. So there's a lot of like geopositioning, like the adjustments, all these things basically could be solved, but then not there yet. So we're trying to hack them, trying to find our ways, but still kind of some use cases can't be delivered in such a manner that, because technology isn't there yet, to be as precise as we want to have them with clients and architects. And then another use case, or project, basically, what happened. So there's this project, House of Research, Technology, Utopia and Sustainability. This project basically took another route from the client side. So basically, we got a clear goal in terms of what we have to achieve as sustainability goals, and we got a plot. We got no room program like fixed one, and we got all the engineers and consultants from day one on board. So the whole thing flipped over basically and was more a goal-driven or basically approach where we had to really understand in an early phase which pieces and elements have which impact. So topics of circularity, reducing embodied carbon and operational carbon. And that led in an early phase to that basically, which looks great, but it's a problem. Basically because the client had some ideas, or we as well kind of wanted to investigate into let's say, constructability, carbon footprint, all these things, which leads currently to an over-modeling. But unfortunately, the BIM packages are set up like what you see is what you get. So we need like abstraction levels, basically, and multiple level of geometry or a level of information as well. Let's say the geometry is the bigger issue here, that we can operate back and forth. So this is something, this as well, we see this is something not really solved, and the tools aren't there yet, that we can go very deep and zoom out and change maybe radical things again, and then have still kind of the updated version of that. Because it exists, this approach, no? So we have projects for the Roche, for the pharmaceutical company in Basel. We built these two big towers and the stepping towers, which is their research facilities. We took very much together with the client a modular approach. There's a lot of coding, scripting, external companies involved there, really to rationalize and to have like a plug-and-play principle for that building. The reason is because the power of the company lies in the researchers there, and they have to adapt to all the technology changes in pharmaceutical industry. And so basically they have to as well adapt the building. So everything needs to be modular. And this is kind of still like a heavy lifting, I would say. And this is something we as well we can achieve it. Let's say we're 1.5 there. So we can realize we build those projects. It's a huge investment, and basically what is built there, you can see almost all the buildings are finished. But it's not easy to manage. I think that's something we would as well think about. BIM 2.0 would help us there massively to increase like efficiency in the working. So what we created sometimes is this is not complete, quite obvious, but it's kind of, there are some things that are very like time consuming. So when we go from 3D model to image making, there's still kind of a gap, no? It could be way more streamlined. Things could be much faster. That's why we develop these tools to get in between. Extended reality, normal directions, all these things we kind of trying to basically fish out and reduce the problems, but it's kind of not that this is super fluent as we wanted to have it. So with all the services and use cases, we increase complexity. With all the demands from clients, we increase complexity, and therefore we have to manage those. And therefore we need those tools that are able to manage that. Open source. This is something basically that bases on some ideas we already heard. So we decided that to put all our small developments, basically we had open source. This is basically, you can scan that if you want to, just go to GitHub, you'll find it easily. So as I said, there's some tools we already had there. It was kind of a testing with Revitron based on PyRevit, basically. But I think the biggest, let's say, thinking behind that was, we're not a software company. We're an architecture company with people interested in design technologies, and people come and go again. So what we had in the past is We had a lot of developments, and they got kind of, let's say, once the person left, they were abandoned again. So we thought, okay, first of all, we have to put everything on a Git structure that is kind of better documented, kind of more documentation, more documentation, more documentation. But at the same time, when people leave, the ownership as well is kind of lost. So we decided to have a more sustainable development, basically, to on purpose put those things on our GitHub, and the people contribute with their private accounts, basically, to have like the continuation of their basically work commitment. And we see that it runs, and we hope that this will increase in the future. And the same thing when you put things open source, you think about, hey, okay, we have to think makes better. So we had BIMLite, and then we worked the core. So we created this Rython core that is the data visualization core for all the other services. So we rewrote the whole code before we put it online, just to make it as clean, as nice, and as performative as possible. And then we added some more. I mean, this is super simple too, but I think the low threshold approach, I think it's the important one. We teach half an hour, that's the tool, there's the documentation, go for it, or even less. So it's kind of this is the basically the minimal invasive approach, but it leverages projects. And then there are some other things that basically are not 100% open source, but in a way, it's kind of an open approach. So, for instance, we just had like one of the projects we did at the Berner Fachhochschule in Biel, basically, that is a wood school, basically, that trains people in let's say, the whole wood industry. And the circularity approach basically turns it, how you basically, inverts the design process in terms of how you define materials. And what we did there, I mean, there are a lot of tests we did, like we combined certain things like circularity, on-site, let's say, planless fabrication through augmented reality, let's say on-site fabrication with Shaper Hub. And basically the whole idea here is to think about, hey, how does it run with circularity? How is the data structured that we can put it in the models again? And this is something we kind of expand now. We're trying to move that on the building scale together with a research project in Switzerland, with some as well with Roche and ETH Zurich and others. Basically, hopefully we get that grant to basically bring that on the next level. And this is as well something we see as well as an important, let's say, I wouldn't say open source, but openness and community approach that is important, because we all benefit for that, and the problem is too big for one company to solve. And maybe one of the last things I want to showcase, so we did a lot of things with, we call it Building Analytics, which is our performance team, where we created dashboards for this, in this case, PV potentials. And we as architects, we want to have like nice and clear, basically, representations, and therefore it's very hard for us sometimes basically to adopt to tools sometimes, so that's why we develop as well our own tools. And when we looked at the whole LCA approach, we figured out, hey, we should maybe look out at the industry, so we reached out as well to Link.io and Arup and saw, should we really start our own developments? And I talked to as well some others here in the crowd, and we kind of, each and every company works on the same issue currently, like the whole LCA, embodied carbon. And we tried to open up, somehow still we figured out, okay, we need our own approach. So I think it's a big question of how we overcome this. And that we're really able to create like these dashboards and these, let's say, analytics we need, basically, which we didn't found currently on the market, they're out yet. So one of the tools is, this is another tool, Revitron, Qualitron, we have some. So this is like a package as well, data visualization, it's super fast and it's as well low-key in a way. Basically, we're faster because we don't use the native functions in the tool. And this is something we figured out, hey, okay, we can utilize that for our LCA development. And then basically, I mean, this is not finished, it's just one thing, but I can showcase another thing in a second. But in a way, the idea is really to work where the data lives, basically. Architects should understand what is the impact of what they're doing. And we could not find that, basically. So that's why we decided to go on that route, and basically still open for discussion with other companies, basically, to basically push the whole approach. And what we did is like get it out of the black box, meaning in that case the BIM models, is really kind of, okay, what is the structure that we need? And maybe we wait then for Greg to finish his structures, and then we can basically, through API calls, let's say, hook them up. But I think the interesting thing is like, we need open data. So we will have in the future more platforms. We have currently already multiple platforms we operate, and we need to get it out of these models, out of like the file structure, and we need to host it in our way, in a way. And so basically we created this like tree and forest analogy, basically that we can basically remap the model, bring it out, and then assign basically to specific parts of that, basically our build-ups in that case for LCA. So this is kind of very interesting for us, because it's very complex how to basically assess an LCA. And sometimes you do only the facade, sometimes you're missing the basement, sometimes you're having the structure but missing that part. And we need as well to understand what we calculate. So we need kind of this abstraction layer that it's really clear that you don't compare apples and pears. And now the final chapter, what's next? I mean, AI is quite obvious. So we started with some creation with images, like, hey, can we use that for renderings? Maybe legally a problem. Then we looked into more controlled ways, like here with Veras, basically, where this is interesting because you have a design, you have an idea, direction, and then you iterate over that. I think that's something what we're very interested in. But the interesting thing is maybe the predictive simulations as well, like the whole wind simulation, stuff like that. You see in other platforms. But this is something that kind of may change a lot. So we haven't introduced it, but it's a new specialist in the team. So we have our chatbot basically that kind of you can talk to, and basically that chatbot basically has some, in a way, awareness, because we don't go straight into ChatGPT in that case. We create in between and basically introduce a framework that operates in between, that we can host that service on multiple platforms and basically are independent from the tools. And I mean, the crazy thing here is that this development is like 3 weeks only because you use Copilot for developing the code. And the other thing is like, maybe it's really breaking because you can even generate code out of it. So basically that's a framework behind. So we use LangChain between, and then we can really kind of be more flexible in a way in the future. Well, I think this is just one slide from an initiative in Switzerland, open source construction. I think it's very, very interesting of how the industry will continue, especially when I think about new tools. What does it mean for open data? And I think it's really important for us about how do we collaborate as an industry, especially about the topic of sustainability, that we have to do something together. And I think this is very urgent, and I enjoyed the talk here. Let's have a talk later. Thanks a lot.